Hey, hey, hey. We're selling more and more books, my friends, and it is great. Welcome back to Factversity. Hey, maybe we should change from Gabversity to Factversity. Nah, Gabversity is easier to pronounce. Where facts don't care about your feelings. Melitza Sada. Speaking Human, The Tragedy of the Retarded Genius by Adrienne Ferguson. There it is, my friends. All right, so we're going to go one more time over the particle in the box. Here is the box. And the particle. Hey, I was hoping you'd come. Ah, Melitza Sada. I'm sorry. I'm in the middle of scoping. Don't call me. Very annoying. Here is our particle in the box. Alrighty, there it is. So our particle is bouncing around in the box, and we need to find out the wave, the 3D wave, that tells us where the particle is going to be. Now, I did this lecture, I think 2 or 3 lectures ago. I'm going to do it again, and this is going to be much more mathematically based. So let us start again. The equation for the particle inside the box, where the potential is 0, works out to be this: minus h bar squared, which is a slither of a pixel size of the universe, over 2 times the mass. And that multiplied by, this is the second derivative in 3D all squared, which I've done before. All right? And that equals the energy multiplied by the 3-dimensional wave. There it is. And that wave happens to be x, y, z, right? So that means it's a wave in 3 dimensions, in the x, y, and z direction. Okay. Here is the equation. And now let's expand this. So that's minus h bar squared over 2m, right? Outside of d2 dx squared plus d2 dy squared plus d2 dz squared equals E of the 3D wave, x, y, z. Right. I've just expanded that. That's all I've done. So that equals that. So the second derivative, remember, it's the equivalent of, like, it's analogous to acceleration. So, you know, acceleration is like the second derivative if your location is the original data. Right? So first derivative speed, second derivative acceleration. Oh, come on. This guy. God. All right. So remember that this 3D wave, right, is made up of 3 1D waves. Does that make sense? Have a look at this cube. This cube is made up of the height, the width, and the depth. And when you multiply them together, you get the cube. And that's the same here. Imagine that that's height, that's width, and that's depth. Oh, thank goodness. Imagine if that's height, width, and depth. Yay, multiplied together, and that'll give you the 3D wave. So, you know, a wave moves like this in 1 dimension. In 3 dimensions, it would be like a sphere, you know, going in and out. Hey, 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 in and out. Alrighty, so cube is made of the same thing as my rock hard dick. You have a wooden dick, do you? Well, keep it away from flames, my friend. Oh, that is too good. You know what's funny? It's your timing that's funny. You have very good sense of timing, even though the joke is so stupid. Correct, it's wood. That is too good. Sign of intelligence, unfortunately. What are you going to do? All right. So now we can separate this, right? This guy is too funny. I swear I leave him because his timing is just immaculate. Unlike his rock hard little dick. Too good. Okay. D2 dx squared. So I'm just repeating this line. Okay. Equals the energy multiplied by, okay. Now I'm going to break up this wave. I'm going to break it up into x of x, y of y, and z of z. Okay, so this is that wave, but now it's 3 waves in 3 different dimensions multiplied together, just like this cube. Too funny. All right, And now I'm going to put this on this side, which means it's going to flip over. Right? I'm going to bring this over to this side. Okay, let's do it. So this implies that d2 of dx squared plus d2 of dy squared plus d2 of dz squared, okay, over this wave x, x, y, y, z, z, okay. By the way, the fact that these can be separated only happens in this universe. Mathematics shows us that that is not true in all possible universes. Okay, equals 2m over h bar squared and a negative of that multiplied by e. So we've just done some basic algebra and flipped everything across, right? Okay, the second derivative of the wave function, right, is going to give us, I will show you right now. These things are going to disappear when you divide that by that, and then when you divide that by that, these two will disappear. When you divide that by that, these two disappear. Now that's just mathematics. I'm not going to teach you why that happens in this case because it's only a physics course, but there's a mathematical proof for that in separation of variables if you've done third year mathematics. Okay, so this implies, right, that 1 over x, which is that x of x wave, I've just shortened the notation, so that's that 1 over this, by d2 dx squared plus 1 over y d2 dy squared plus 1 over z d2 dz squared equals minus 2m over h bar squared e. Alrighty. So now we have just separated the whole equation. Now a truck comes. Jesus, man, this street is the busiest street in the frickin' planet. Unbelievable. Alright. Sorry, I'm just... Yeah, I know, it's frickin' insane. I don't understand what the hell. Alright, so now... Read your book. Oh, you read your book. You read the book. Oh, how cool is that? I'm so glad you love the book. That makes me very happy, man. Haven't moved home. Nah, I haven't moved anywhere. All right. Thank you very much. You made my day, my friend. All right, cool. So, as we can see, here are all of these cars accelerating together to give this thing. Alright, so clearly their acceleration is in common, which means that that's a constant, okay? And if that's a constant, then have a look at this. We can say that this implies that constant 1, kx, plus constant 2, ky, plus constant 3, which is kz, equals, and I'm gonna make them squared, right? And that's just for mathematical reasons. It doesn't matter, constant squared or the constant. You could call that another constant, which is doesn't really matter. Equals. Where am I? What have I done? What have I done? What have I done? What have I done? Let me make sure I'm doing the right thing. Have I done the right thing here? I think I have. Make that equal to 2m e over h squared. Okay, so I'm going to make that equal to that. Okay, I'm just going to define it as that for now, and I'll show you why in a sec. Which implies that the energy levels of this particle in a box is going to equal h bar squared over 2m outside of k squared x plus k squared y plus k squared z. Now, okay, I'll tell you what I've actually done here, right? So all I have done is I have redefined energy in terms of these three new constants. And there's a reason for that. And that's because this thing here, okay, this thing here and this thing here, you can look at them as constants because they are completely different functions, and yet altogether they make this thing here. Now that is a mathematical rule, and I've explained it before, but I'll explain it again. It is like this. If, right, if Melitza Sara, right, and Bill Sunergone, Sunergone. I'm just going to pronounce it like that. So if Melitza and Sunergone are both accelerating in their separate cars, right? They're both accelerating, and yet they are staying in line with each other. Okay, abyss. That means that relative to each other, Greek, Sunergonish. Hey. All right. If you are both accelerating in different cars and yet you are both able to talk to each other, then relative to each other, you must be not moving. Okay? So, you know, you're both staying with each other, and that idea of not moving is the constant. Now, that is not a proof at all. I'm just giving you a conceptual reason, but the actual proof, if I ever end up getting enough people to do a mathematics calculus course, I will show you the proof. So at the moment, you'll have to be a very good religious person and take it on faith. Oh, God. Just waiting for the truck. This is our garbage truck down here. I don't know if you guys do the same thing. They come to you. Those guys make so much money. Good on them. Oh, and now this other guy's freaking... This other guy's now freaking... Oh, just... Anyway. All right. So, what we said, right? We said that this is this, okay? That is that, and that is that, okay? Now, why did we do that? I'll show you why, okay? 1 over x d2 going to Sydney. Oh, no, I live in Sydney. I know, it's freaking crazy. Ah, Melitza Sada, sorry, I should confirm. I was in Wagga for university last week, and then I drove back to Sydney, back to my home in Sydney, yes. Okay, so d2 over dx equals k squared x negative. All right, yeah, sorry about that. All right, so now we're saying this, all right? Now, how does this work? It doesn't really matter. You can make that. Okay, so what happens here, right? What I did here was actually this, okay? So that is the negative of that, obviously, because that's why the negative disappeared. If you look, there was a negative there. Doesn't really matter. That's just a mathematical detail. Oh, this guy. My God. This is the worst lecture. All right, that implies that d2 dx equals the function x, right? Multiplied by minus k squared x. Okay, so now we have this. Oh, excuse me for a sec. Let that refocus itself. Okay. Now here we have an interesting equation, right? What we're saying is that this function, this wave, multiplied by its own fingerprint squared, gives you the acceleration of the same wave. How weird is that? That is the weirdest thing. That's like saying, for example, if I travel at 60 kilometers an hour, my acceleration is also at 60 kilometers an hour per hour, right? Like my acceleration happens to equal my speed. That's not what we're saying, but it's the same type of thinking where, how the hell does that happen? Well, there's only one function that can do that. And anyone who's done second G calculus at uni will know what that function is. And that function is this. This implies that this function x of x, this wave equation in one dimension, is going to equal ax, which is the amplitude, okay, sine kx, which is the fingerprint x, plus b of x cos kx x. All right, so that is the wave, right? It is one wave that goes like that, another wave which goes like that, which is slightly shifted, and together they add up, and these are different amplitudes, and create that wave. That is the only type of wave that when you get that wave's second derivative, quote unquote acceleration, you end up getting the same freaking wave multiplied by its own fingerprint squared. That is a mathematical concept. Turns out it works exactly in quantum mechanics. Exactly. It's so bizarre that mathematics is what's happening in the universe before we discover it. It's like the whole universe was written in mathematical code. I love that. If you make that assumption, then there is something more dangerous that comes up and will blow your headspace. There is infinitely more mathematical code that does not fit in this universe than there is that does fit. And so you can either think that that's just a random coincidence, or you can think that there are infinitely more other universes that each have different parts of that total code that mathematicians have figured out. Right? So imagine, for example, you get a software program and you realize that only like 1/10000000th of a billionth of a percent, right, of that software program is being used in this game that we're playing in life. I agree with you. Yeah. Right? Imagine if you discover that, because that's sort of what I'm looking at when I see mathematical code, right? You realize that like an infinitely small amount of that code is being used in our universe. And there's all this other code, right? And you wonder, why is all that code there? It could be that there is so much code that it's just luck or coincidence that some of that code exactly maps onto our universe. It could be. Or it could be that there are infinitely other universes to let us know we aren't alone. Okay. How does fractal geometry relate to particle physics? That's a very good question. Who said that? Kindzo. Oh, I thought Abyss was going to ask that question. My friend, that's the question of the day. Abyss has given up his place just one time. It does not relate. In terms of basic quantum mechanics, it does not relate. It relates in a much more advanced level in the sense that there are multiple dimensions. And that is a way to understand how borders can actually exist. Because there's a problem with defining borders based upon a certain equation. And the problem is that when you zoom in, you lose resolution, right? Now, in this universe, that is not actually a bad thing to a certain degree, because this universe does have a maximum resolution, right? We don't work on a continuous basis. Can't talk right now. Don't be silly, my friend. You come and stay and sit. I didn't see Melitza's comment. I should go back to that. Sorry. Definitely not me. Yeah, I think we agree on that one. But fractal geometry allows you to zoom in and increase the complexity as you zoom in. So that part is brilliant, because you can zoom in onto the border of Ireland, for example, and the more you zoom in, the more of a resolution you can get. But in quantum physics, we have a limit on the resolution we can get. Hello, Dr. 6Z, as opposed to 7Z and 8Z. Why was 6 scared? Because 7, 8, 9, ha ha ha. Lol, autism, honesty. That's how it works. Anyway, so there is the wave. Now, what's interesting, right? I can do this for each of the 3 dimensions, okay? So for the other dimensions, we'll get the same thing. Now, I'm just going to rip this off. Hey, I'm going to rip it off. Okay, so that's 1 page down. Okay. This is how I'm now writing my maths, because the equations are so long, I've turned my book sideways. Why is this important? Well, remember this. Here is the cube. But now we've ripped off the face of the cube, right? So now, instead of looking at the whole cube, we're looking at 1 dimension. Now, in this dimension, if the wave is here, okay, right, that's at 0, okay? Now, we know, okay, 1 second. We know that at 0, the particle is not going to be at the edge of the box, right? Because the box is there, so it has to be next to the edge of the box. Okay, so obviously at the edge of the box, it's going to be 0. Okay, it's not going to be inside the wall of the box. So that means that the wave function at 0 is going to equal 0. And that's the same for A, if the box has a length A. Ripped off the face of the cube. So violent, I know. Just, all right. So I wish I could show you this on a computer, how amazing these waves look in 3 dimensions. You could do it yourself. What you could actually, just a quick diversion, as we like to do, right? Get your family or friend, right, to do this with you. Get your hand, go into a bathtub, right, and just move your hand up and down, right, to make a 1-dimensional wave. Then, for example, Melitza, get your husband or your partner or your brother, sister, whatever, or even, you know, your child, if you know what I mean, or your niece, nephew. You're doing this, get them to put their hand perpendicular to your hand and do the same thing. And what you will see a two-dimensional wave, because you're propagating one dimension and they're propagating the other dimension 90 degrees to you. And that interaction will make a two-dimensional wave. And have a look at the wave, how it moves. That'll show you a two-dimensional wave. If you want to see a three-dimensional wave, you'll need to get a third person to put their arm downwards and do the same thing. And then, if you could see into the water, you will get a beautiful pulsating blob of a three-dimensional wave, which moves like a pulsating sphere, like a heartbeat. And that, my friends, is the 3D quantum particle wave. That is what it looks like in 3D. And that is 3D, but the wave is actually in 4D, right? So that's a snapshot of the wave. That is a beautiful thing. So that's something you can try with your family at home. Okay, moving on. So we know that at the edges it equals 0. Well, if that equals 0, that must imply that AX sine of the fingerprint in the x dimension of x plus b of x sine kx of x equals 0. Well, how is... Oh, sorry, that's supposed to be a cos. Sorry, I stuffed that up. All right, how is that going to be 0? Well, that means that that and that are 0. Well, cos of 0 is 1. Okay, cos of 0 is 1. Sine of 0 is 0, which implies that 0 plus 1 times b of x equals 0, which implies that b of x has to equal 0. So therefore, the actual equation is ax sine fingerprint of x, x. So that's the equation, right? Because b of x is 0. So that cancels that out. All right, but we also know that on the other side, where x equals a, it's also 0. Because the particle is not going to be stuck inside the wall, right? That's not going to happen. So x of a equals a of x sine k of x a, which equals 0. Okay. Hey, D Sims, another book fan. Love all you guys. Don't forget to download the book, the ebook, have a read, it'll blow your mind. Alright, so. Oh, one more time. There it is, our beautiful, gorgeous book. With the beautiful gab on the front. Alrighty. So, how is this going to equal 0? Well, this is going to equal 0 when sine k of xa equals 0. That's the only way. I mean, you could make a 0, but then that's just cheating. It's an easy answer. But sine of kxa equals 0. Well, how is... Well, sine of what equals 0? Sine of what equals 0? Sine of n pi, which implies that n pi equals kx of a. Because... What is that? What does that mean? I'll show you. I'll graph it. Let me graph it for you. Here is the sine wave. Okay? Like electricity, right? When is it 0? Well, that's 0. That's pi. Jeez, this street, man. 2 pi, 3 pi, 4 pi. Whose street is that? Whose car? Oh.
What's happened?
Just went off by itself. It's my dad's car. Alrighty, what are you gonna do? E-way tag. Could have been the E-way tag.
على الهيت. Yeah, على الهيت وقع.
Yeah, E-tag probably moved in the car. There you go. Never know what you're going to get at Gabversity. So look what equals 0, right? Sine, shut that damn alarm off, school's in session, I know. So pi, 2 pi, 3 pi, 4 pi, 5 pi. In other words, n pi. N pi, and n is 1, 2, 3, 4, 5. So n pi equals kxa. And so this implies that k of x equals n pi over a. With your intellect. I think the car alarm was making sound waves, where n equals 1, 2, 3, all the way to infinity. Right? So there you go. So now we know what k is. So now we figured out this wave equation. Okay. So let's just come down here. So therefore, the wave equation in the x dimension, okay, equals ax, which is the amplitude, sine of nx pi, because it's n in the x direction, over a. And that should be an x there as well. Okay. Now, let's make sure I've done this right. Let's make sure I am right. I am correct. Excellent. So there you go. So now we have discovered the equation in the x dimension. Now we can do the same for the other two. I'm not going to do that now, right? But you'll end up getting the same thing. So if you do the exact same thing, and you're going to get that y of y and z of z, okay, it's going to equal ay, az, and that's going to be sine, it's going to be sine, it's going to be ny pi over ay, it's nz pi over az. So there you go. So now we have all three dimensions. So that means that the cube, and remember the cube is length by width by depth, or height, or whatever you want to call it, right? That means that the cube wave, the three-dimensional wave, as a snapshot in time, and here it is, okay, x, y, z equals, it's going to be the amplitude of x times the amplitude of y times the amplitude of z by sine of nx pi over ax multiplied by sine of ny pi over ay multiplied by sine of nz pi over az. And there it is, we solved it. Now we haven't got the amplitude, but we can easily solve for that, which I won't do at the moment. So there you go, that is the three-dimensional wave. This one here is Melitza Sada moving her hand this way. This one here is Abyss moving his hand perpendicular. And this is, I don't know, D Sims or Sunergon or Google Anithis going into the water. And that's the three-dimensional wave. I'm going to show you what it looks like actually. I got a photo off the net and I've showed you guys this before. Let's see if I can, there they are. So here is a photo of some three-dimensional waves from earlier. And I've showed you this before, but there you go. This is the same. This is a four-dimensional wave, and these are snapshots in time that are 3D snapshots. So each one of these is a 3D snapshot of a 4D object. So we can't see the object in our brain, but the object is all of this. But as they intersect with the 3D plane, we get that, right? That's hard to understand, right? It's like, for example, if you look at this cube, right? Imagine if that's a 2D object and then you rotate it, you get another shape, you get this shape, then you get that shape, right? That's what's happening here. As you rotate this in time, you get different shapes. So congratulations. That is a repeat of how to get a 3D wave equation of a particle in a box. Not too hard. I'm glad you said that. I was just about to say that is by far the simplest wave equation you can ever do in 3D. So what we're actually going to do later, and I'm not sure if I'll do this on Gapversity because it might be a bit too complex, I don't know. I love breaking it down for you guys, it's awesome. I think I get more fun out of it than you do. Anyway, yeah, later on what we do is we're gonna use two-dimensional angles to make three-dimensional spheres, and then we're going to use two-dimensional angles plus the third dimension of the radius to give us a four-dimensional sphere. And mathematically the four-dimensional sphere is just amazing, because what happens is that the radius changes in the fourth dimension, so you get this pulsating sphere, which is actually a four-dimensional sphere, which is a lot of spheres in our mind, but it's actually one object. Those are the best waves. Oh, that's nice. Well, I hope you can make your partner laugh just as much, my dear. So this was brought to you by Speaking Human, The Tragedy of the Retarded Genius, available ebook. You can go to the Pompa store. So, the true story of an undiagnosed autistic savant who learned to mimic human behavior whilst being abused by both teachers and students alike, ultimately and wrongly arrested as a Jewish spy in Arab lands, amongst other misadventures, until succumbing to a suicide-induced coma, only to meet the woman who would transform him into the CEO of a multi-million-dollar company, which would eventually lead him to the ultimate tragedy. So that's it. And the book ends with the second book opening, The 5 Years Exile. And that's when I escaped out of Syria when the rebels took over. And coming back. Laughing is healthy. Absolutely. Laughing is healthy. I think that's all I've got for you guys. Here's where I got mine. Read it in one evening. From Amazon. Oh, wow. It's on Amazon. Okay. It's on Amazon. I didn't know that. There you go. If you get it from Ex Libris, I actually get my full commission. If you go to Amazon, I think I get like nothing, like 50 cents. But you can go to Amazon, I don't mind. Whatever you want to do it. And we've got our speech coming up, which is exciting. And we're interviewing on Gabsmacked this guy who's come from the place that ISIS took over. His name is Johnny Meso. And he is the head of the Syriac community around the world. How do I get a signed copy? If you want a signed copy, you've got to go to GoFundMe/Gabsmacked and put in $50 Australian. And as soon as the actual printed copies all come out, like the whole bunch, they're coming in 3 months. I'm having a massive launch in 3 months' time, like an actual launch. It's going to be all over radio, TV, like the whole thing, right? And book tours. Then I'll be able to sign a beautiful copy and send it straight to you. Just make sure you make your donation anonymous and put in your postal address. Where in Australia are you from? I am from Sydney. How about yourself, Queen of Avocado? Avocado is a very healthy fat, keeps you full for a very long period of time. Anyway, guys, I'm going to love you and leave you. And I'll probably do some more maths myself. Ah, awesome. Awesome. We should meet up. Come to the next autism speech. Go to Gabsmacked on YouTube. Look at the second live autism speech. If you like it, come to the third one. Crowdfund my launch. Well, that's what GoFundMe is. The GoFundMe was the crowdfunding. And I thought I'd give you more than welcome. Parakalo. Adelfosh. All right. That's it. That's all I got. I'll see you guys later when we talk about the success of the Japanese culture. Give you all a big hug. Gabversity, facts don't care about your feelings.